The Pigeonhole principle states that if k is a positive integer and k plus 1 or more objects are placed into k boxes, then there are at least one box containing 2 or more of the objects. Here is an example that shows how the pigeonhole principle is used. How many students must be in a class to guarantee that at least 2 students receive the same score on the final exam if the exam is graded on a scale from 0 to 100 points? Solution: there are 100 possible scores on the final. The pigeonhole principle shows that among any 102 students, there must be at least 2 students with the same score. The generalized pigeonhole principle. It states that if n objects are placed into k boxes, then there is at least one box containing at least n over k objects. Example: what is the minimum number of students required in a discrete mathematics class to be sure that at least 6 will receive the same grade if there are 5 possible grades A, B, C, D, and F? Solution: the minimum number of students needed to ensure that at least 6 students receive the same grade is the smallest integer n, such that ceiling n over 5 is equal to 6. The smallest in such integer is n is equal to 5 times 5 plus 1 is equal to 26. If you have only 25 students, it is possible for there to be 5 who have received each grade so that no 6 students have received the same grade. Thus, 26 is the minimum number of students needed to ensure that at least 6 students will receive the same grade.
The next topic is permutations. It states that the permutation is an ordered arrangement of any element of set. The permutations of n different things taken r at a time. The formula is n permutation of r is equal to the n factorial divided by the quantity of n less r factorial. Permutation of object with sum are alike. The formula is n permutation of n is equal to the n factorial divided by the quantity of p factorial times q factorial times s factorial and so on. Circular permutation. The circular permutation has two cases. The first one is if clockwise and anti-clockwise orders are different, then the total number of circular permutation is given by n permutation of n is equal to the difference of n and 1 factorial. The second one, if clockwise and anti-clockwise are taken as not different, the total number of permutation with reflection symmetry such as bracelets is given by n permutation of n is equal to the difference of n and 1 factorial divided by 2 factorial. Here are some examples of the permutation. First, how many permutations can be made from the word Mississippi? Let n be the number of letters is equal to 11 and 4 I's, 4 S, and 2 P's. The solution is P is equal to 11 factorial, the number of letters, divided by the product of 4 factorial times 4 factorial times 2 factorial. The answer is 34,650 permutations. Here are another example. How many ways can 4 people form a circle? In this example, we will use the first formula of the circular permutation, and that's the first case. The formula is n is equal to the difference of n and 1 factorial. N is equal to 4 less 1 factorial, and the answer is 6 ways. The last example is how many bracelets can be made from 5 differently colored beads. The formula is n permutation of n, or we can use the second formula of the circular permutation. We use the second formula because second case states that the total number of permutation with reflection symmetry such as bracelets, and in this example we will find the number of bracelets formed. So we use the second formula, and the formula is the quantity of n less 1 factorial divided by 2 factorial. We substitute the 5 in n and then solve, and the answer is 12 bracelets.
Combinations. Combination is a grouping, arrangement of any element of set. Formula: n combination of r is equals to n factorial divided by n less r factorial multiplied by r factorial. Here's a problem. How many poker hands of 5 cards can be dealt from a standard deck of 52 cards when r is equals to 5 and n is equals to 52? The solution for this problem is 52 combination of 5 is equals to n factorial divided by n less r factorial times r factorial. 52 factorial divided by 52 less 5 factorial times 5. The combination is 2,598,960. Here is another example. 6 people are on a sinking yacht. There are 4 life jackets. How many combinations of jacket are there when r is equals to 4 and n is equals to 6? The solution for this problem is 6 combination of 4 is equals to n factorial divided by n less r factorial r factorial. 6 factorial divided by 6 less 4 factorial times 4 factorial. The number of combinations are 15 combinations.